Hi everyone, welcome to another session of the HPL files. In today's session, we will be looking at the velocity and acceleration in simple harmonic motion, particularly the values and the direction of those two quantities. Let's begin. Here we have an object connected to a spring, and the spring is fixed at one end. Now, this is the rest length of the spring, which means it's neither compressed nor stretched at this position. Since that is the case, we can say that at this point, this will be the equilibrium position of this object. Or we can denote that as x is equal to 0. Next is to identify this point, which will be the negative maximum displacement, as well as this one. And it will be the positive maximum displacement. Next step is to compress the spring by displacing this object to the left. Okay. Since we are assuming that this setup or this object will oscillate under simple harmonic motion or will undergo simple harmonic motion, we'll then look at the force exerted by the spring onto this object. Okay. Now, once we release this object, the object goes this way. Since the object is moving to the right, therefore we can say that the velocity of the object is to the right. Now the question is, why did the object go to the right and not to the left? Notice that at this position, the spring is compressed. Now, the natural tendency for the spring is to go back to its original length. Since that is the case, this spring will exert a force on this object that's directed to the right. Now, notice that at this position, when the object is at this position, the spring is still compressed. So that means the spring will still exert a force directed to the right. Okay, and that force is exerted onto this object. Now, since that's the force felt or the only force felt by this object along this direction, then that means the acceleration or the net acceleration of this object is also directed to the right. Since velocity and acceleration are in the same directions, that means the object speeds up. Okay. Let's consider this next position. At this point, the object has now reached its equilibrium position. But take note, the object will not miraculously stop once it reaches this position. Why? Notice that before it reached this position, it was moving to the right, and its speed was increasing. That means when the object reached this position, it will have a velocity directed to the right. Okay. Now, notice that the spring, on the other hand, is now back to its rest length. Since it's back to its rest length, therefore it will neither push nor pull the object, because at this position, the spring is neither compressed nor stretched. That means the spring will not exert any force on this object. If there's no force exerted on this object, therefore there is no acceleration, which means acceleration is 0. Since initially the speed was increasing, or the magnitude of the velocity was increasing, and when it reached this point, acceleration is 0, therefore, at this point, the velocity is not changing because, again, acceleration is 0. Which means we can say that at this point, the object has a maximum speed, or it achieved the maximum magnitude for the velocity. Now, since the object has a velocity at this position, then it overshoots to this next position. At this point, the object is still moving to the right. So the velocity is directed to the right. But notice that the spring is now stretched. Again, the spring just wants to go back to its original length. So for it to go back to its original length, it will exert a force on this object that is directed to the left. Okay? Since the force exerted by the spring on the object is to the left, therefore the acceleration experienced by this object is also to the left. Since velocity and acceleration are now in opposite directions, the object slows down until such time it reaches this position, which is its maximum positive displacement. At the maximum positive displacement, the object cannot go any further. This is the point where it momentarily stops, which means the velocity is equal to 0. Okay, now notice that at this point, the spring is stretched the most. So if you imagine stretching a very thick spring, the longer it stretches, the harder or the more difficult it will be for you to actually stretch the spring. So at this point where the spring is stretched the most, this is the point where the spring exerts the greatest amount of force to this object. Since the greatest amount of force is applied to this object at this position, therefore, the acceleration experienced by this object at this position will also be the greatest. That means the acceleration, which is directed still to the left, will have a maximum value at this point. Now, let's copy this last position of the object to this next slide. Okay. And then, of course, after reaching its maximum positive displacement, the object will now reverse in terms of the direction of its velocity and will now go to the left. So its velocity is directed to the left. Now, notice that the spring is still stretched. Since it's still stretched, therefore it will still apply a force or exert a force on this object to the left. Therefore, the acceleration experienced by the object is to the left. Since velocity and acceleration are now in the same directions, then the object speeds up. Next, when the object reaches or goes to this position, which is again the equilibrium position, the object will still have a velocity directed to the left. But if you look at the spring is now back to its rest length. It's neither compressed nor stretched. That means it will not exert any force on this object. That means there is no acceleration experienced by the object at this position. Since the object was initially speeding up before reaching this point, and at this point there is 0 acceleration, we can say that the speed is at the maximum value at this point. Or if you look at the velocity, it will have a maximum negative velocity at this point. Negative because the velocity is directed to the left. Now again, the object overshoots and reaches this point. At this point, the object is still moving to the left, so velocity is directed to the left. But take note the spring is now compressed. So the force that this spring will apply to this object will now be directed to the right, which means the acceleration is also directed to the right. Since velocity and acceleration are now in opposite directions, the object slows down until it reaches its maximum negative displacement, where the object momentarily stops. That means velocity is equal to 0. And this is the point where the spring is compressed the most. So it's similar to when the spring is stretched the most. Therefore, that's the point where this spring will exert the greatest amount of force directed to the right. Okay, and that force is exerted on this object. Since the greatest amount of force is exerted at this position, therefore the object will experience the greatest acceleration. And again, that acceleration is directed to the right. Okay, so as a summary, we have seen that when the object is at equilibrium position, the velocity of the object will either be a positive or negative maximum, while its acceleration is 0. On the other hand, when the object is at the amplitude, its velocity is 0 because it momentarily stops, while its acceleration can either be a positive or negative maximum. Okay, so that's it, guys. I hope you have learned something. And as always, thank you for learning with me today. See you on the next session of the HBO files.